In this video, we'll be taking a look at rate configuration on the PM-50D Digital Panel Meter. The PM-50D can measure rate using its counter inputs and scale it to virtually any engineering unit, such as feet per second or gallons per minute, for example. This is made possible by user-configurable rate settings for each of the two digital counter inputs. There is also a third user-configurable rate which can incorporate both of the digital counter inputs. For this demonstration, I'll be configuring my PM-50D to monitor the rate of input A, which I've wired a push button to. The push button will simulate pulses of a flow meter, where one pulse is equal to 1 gallon, and will measure this flow in gallons per minute. Here's a quick look at how the push button is wired to my PM-50 using syncing logic. These inputs can also be wired and configured for sourcing logic or magnetic pickup, and you can find detailed wiring diagrams in the PM-50D user manual. I've already logged into my PM-50 using admin credentials, so I'll navigate to the device menu to get started. From here, click once on Signal Input Configuration. Before we configure the rate settings, it's important to make sure the counter input configuration is correct for the application, so we'll click once on that menu item to expand it. First, we have the ability to select from input A, which is the push button wired to counter one input on the unit, and input B, which is not being used for this example. From there, we can enable the digital filter, select the input logic for the counter, and confirm our logic selection for the input. In this case, I have enabled the digital filter since my push button doesn't have a very clean signal. For the input selection for the counter, I've selected high acting, which means the input will be registered as soon as the button is pressed. Finally, the push button is wired using syncing logic, so I've made that selection for the input. If you've made any changes here, be sure to click Save to confirm your selections before proceeding to the next step. Now we'll click once on Rate Configuration to expand that menu item. The first thing that we see is Rate Type, where we select which rate we're going to configure. Generally speaking, Rate A is focused on input A, Rate B is focused on input B, and Rate C is a special rate which we'll take a closer look at here shortly. For this example, I will only be configuring Rate A since our push button is wired to input A, but after that is done, we'll take a quick look at the other rates as well as the common. Next we see Enable Rate. Click once on that slider to enable. Once you've done that, you'll see some new configuration options available below, starting with decimal point. In this example, I'd like 1 decimal point of precision, so I'll select 0.0. For scaling type, you do have an option of applying signals, but this is only available from the touchscreen of the unit, which leaves us with enter values. Next we have scaling points. For nonlinear processes, you have the option to enter up to 10 scaling points. Since our process example is linear, 2 scaling points will be sufficient. Now we enter our scaling points and display points. Scaling point 1 and display point 1 will both be 0 for all zero-based processes, so I'll leave those as is. Scaling point 2 should be equal to the number of pulses per one engineering unit. For example, since I'm measuring rate in gallons per minute, I need to enter the number of pulses equal to 1 gallon. In this case, the simulated flow meter sends 1 pulse per gallon, so I'll enter a value of 1 here. Display point 2 represents the time base in seconds. Since we're measuring in gallons per minute, I'll enter a value of 60 here for the seconds in a minute. If we wanted to measure gallons per hour, we would enter a value of 3600 here for the seconds in an hour. Next we have display rounding. I'll leave this set to 0.1, which is the smallest option. You'll see that you have the ability to set the rounding up to 10 if needed. Finally, we have our low cutout. This option allows users to set a minimum rate for the PM-50 to display. For example, if we only wanted to display rates of 25 GPM or higher, I would just enter a value of 25 here, and any rate below 25 GPM would be displayed as 0. I'll be leaving this set to 0 for the example to make sure that we capture the full GPM range. At this point, I'll go ahead and click Save, then scroll back up to show you the other user configurable rates. Rate B is the rate for input B. I'll quickly enable this, and you can see that the configuration options are identical to those of rate A. Rate C is a special rate which allows you to perform mathematical functions on rates A and B. I'll click on the Rate C parameters dropdown and you can see the available functions. Finally, we have the common configuration, which is where you'll find options for rate update time and capture delay time. Rate low update time is the minimum amount of time between display updates for all enabled rate displays. Rate high update time is the maximum amount of time between pulses before the enabled rate displays are forced to 0. I'll be changing this one to 4 seconds to prevent the value from going to 0 between pulses, since this is a slower process that I'm simulating. Next, we have minimum and maximum capture delay time. When the rate value is above the maximum rate value for the amount of time entered here, the unit will capture that rate value as the new maximum value. Similarly, when the rate value is below the minimum rate value for the amount of time entered here, the unit will capture that as the new minimum value. Note that you can assign unique delay times for each user configurable rate. Next, I'll just click Save and then we'll navigate to the home page to see our Rate A configuration in action. For this test, I'll start pressing the button wired to input A at a rate of roughly once per second. Since one pulse is equal to 1 gallon, this should give us a value of around 60 GPM depending on how accurate I am with my timing. Keep an eye on the gauge and numeric display as I simulate the flow. And as you can see, we did hit right around 60 GPM as expected. And I'll now start pressing the button at a rate of roughly once every 2 seconds, which should give us a value of around 30 GPM. Once again, things are working as expected and we hit right around that 30 GPM mark, so we know that our rate is being measured and scaled properly. And that's it for PM-50D rate configuration. Thank you for watching.